Hi guys. As you know, this is my first podcast, so we'll hope for the best. Today we're going to talk about the mole. And I want you to take good notes and make sure that you stop and do all of the problems that I tell you to. Okay? Oh, my daughter sent me this and I thought it was cool, so I thought I would share it with you. Isn't that fun? The mole. In chemistry, we use the unit of mole to represent an extremely large number. 6.02 times 10 to the 23rd. And of course, it's also called Avogadro's number. But 1 mole of atoms equals 6.02 times 10 to the 23rd atoms. The same is true for a mole of ions, a mole of molecules. 6.02 times 10 to the 23rd formula units equals a mole of formula units. All it is a number, just like the dozen. There's 12 pieces of gum in a dozen pieces of gum. Just saying. In a dozen pieces of gum. And this is just a much bigger number, is all. The mole is used for very, very small things. Now, obviously, we're not talking about this kind of mole. But let's use this to show you what the size of the chemistry mole is. All right, the animal mole. That was not cool. Let's say an average animal mole is about 15 centimeters long, and that's about 6 inches, and that's what they are, about 6 or 7 inches. I looked it up. If the animal mole was lined up end to end, 6.02 times 10 to the 23rd animal moles would stretch from Earth to the nearest star, Alpha Centauri, more than 2 million times. I find that amazing. A couple more. A mole of donut holes would cover the Earth and be 5 miles deep. A mole of pennies would make at least 7 stacks that would reach the moon. And a mole of blood cells would be more than the total number of blood cells found in every human being on Earth. I mean, it is a huge, huge number. And why do we care? Well, as chemists, we need to take the very small and make it into something that we can actually handle and use and think about and do calculations with. So what we do is we take the very small and we make it into a mole. This is a picture of a mole of carbon atoms. Notice this is one of our scupulas. And just to give you some scale. And here we have a mole of carbon atoms. Of course, that means we have 6.02 times 10 to the 23rd atoms of carbon. All right, so let's take a look at this problem. It says, how many atoms of carbon are there in 3.18 moles of carbon? Well, what we're going to do, and I'm going to try to use the pen here. I'm working on my laptop without a mouse, so we'll see how it goes. We're going to do a factor bar, and we've been doing these since the beginning of the year. And you all know how to do these, so it's no big deal. It's just that what we're going to start with is the unit moles. We have 3.18 3.18 moles of carbon. We're going to draw our factor bar out one place. We want to get rid of the mole, so we're going to put that down here. And I'm going to move it out here. MOL. And I want to change this to atoms. Now we know the conversion factor we're going to use is in 1 mole there are 6.02 times 10 to the 23rd atoms. Now when you go ahead and cancel your unit and then you get your calculator out, you're going to put this in by putting 3.18 and then you're going to put times 6.02, hit your exponent key. Don't do times 10, remember. Hit your exponent key and put in 23 and equals. And that comes out to 1.91 times 10 to the 24th atoms of carbon. Okay, let's do another one. Now, I'm going to give you this one, and then I would like for you to work on it before you look at what the answer is going to be. Okay? Here's the problem. How many molecules of water are there in 1.25 moles? How many molecules of water in 1.25 moles? Go ahead and pause and do this. We do this just the way that we did the other one. Draw out our factor bar one place. Start with what we're given, of course. We're going to put moles down here. And we are going to put molecules up here. Make sure you're really careful about the, we'll do it that way, about the abbreviations you use for moles and molecules. I'm going to put one down here, and of course we're going to put 6.02. Times 10 to the 23rd up here. Cancel. And you wind up with 7.52 times 10 to the 23rd molecules of water. Okay? Again, once I give you the problem, I want you to pause and work this out before going on. How many moles are equal to 2.8 times 10 to the 22nd molecules of anything? Okay, pause now. All right, let's see. And we're going to start with what we're given. 2.8 times 10 to the 22nd. Molecules. Remember those abbreviations, guys, moles and molecules. Don't get them mixed up. This time, we're going to put molecules down here. Whoops. EC for molecules. Ugh. Okay? Now I want you to do the next few problems. Put them in your notebook. I want you to number them. I want you to actually write down the problem. Show your work, show your answer, and of course, don't forget those units. And then I want you to be ready to put them on the board in class and explain them to us. Okay? Here we go. Number 1, how many atoms of gold are in 3.2 moles of gold? Number 2, how many moles of sodium chloride are in 4.8 times 10 to the 24th formula units of sodium chloride? Number 3, if you have 6.89 moles of sucrose, that's sugar, how many molecules of sucrose do you have? 4. If you have 3.7 times 10 to the 58 pizza pies, how many moles of pizza do you have? And gentlemen, I will see you in class. And have an awesome day.